G'day viewers, Alan here. Welcome to the workshop. So, part 2 of my Lynx15 journey. I'll be making the cylinder liner or sleeve, the cover plate for the back of the crankcase, and the cylinder itself. There's quite a bit of work in that little piece, I can tell you. Okay, well, better get straight into it then. I'm setting myself up here to turn the cylinder liner. Basically it's a hollow sleeve, 54mm long, and it's got an external collar at this end, so it's pretty simple, or yeah, it's pretty simple, straightforward turning job. And so I'm going to take a couple of heavy cuts to rough it down to size. This is 40 and my biggest OD on the finished piece is 30, so I've got a bit of material to come off. And I've done this a couple of times more recently. The safety clutch in the apron has jumped, so I decided to have a go at sorting that out. The idea apparently is to increase the preload on the spring in the clutch in here. And the suggestion was to go in a full turn and see whether I started to feel some increase in the spring preload tension. There's half, one, maybe. Well, let's try 1.5. Okay, so let's see if that's fixed it. I'm going to take 2mm off the diameter, or 1mm depth of cut, and I've got to go for about 60, or pretty much the whole length here. Yeah, pretty much the whole length, and we'll see how it goes. Right, that seems to fix the jumping problem. I've got tradies next door again building a house. Yeah, so this is a piece of 40mm 4140 round bar. Anyway, that marked at 38.209. So I'll just update my DRO and take another 2mm depth of cut, another 2mm off the diameter. But I can tell you those chips were coming off hot. There's one that landed against the camera base and it's melted into the plastic. You certainly know these guys when they land on your arms. So I'll leave this end at 32, although the external diameter of the collar is 30, but I'll leave it at 32 for the moment. And this longer piece back here, 52.5, needs to be 28. So I'll take another 2mm off there, for a distance of 52. Yes, we're about on 30 there. So I think I'll change the cutting tools now to away from a roughing tool. Yeah, there's a bit of heat in that, so that's probably going to go undersized when it cools down. Right, so I don't know how much to allow for the cooling down, so I think we'll wait for it to cool down. We'll give it a bit of help and then come back when it has cooled down. So I did actually run the cutter over it once more, set it 28 dead, and got a rather satisfactory result. So we're actually on 28.001 now. Actually on 28, so I'm happy with that. We're at room temperature. So did we in fact get 30.5? Yep. So this is the money shot, aiming at 30. That's close. That's close enough for me. You get lucky sometimes, don't you? Right, that's the outside of that piece finished. In due course I'll be parting that off to leave that collar 1.5mm wide. But now the idea is to dig the guts out of this thing. It needs to be have a 25mm bore right through. And that is going to be the cylinder bore, so that's actually quite important, that one. Well, that generated some heat, but we got there 60mm deep. Right, so I've just taken the last cut. Hopefully this brought this to size. So the nominal bore for this liner is 25mm. I was shooting for 24.95, so I'd have something which I can lap, an allowance for lapping to get a really smooth finish at 25. Well, it looks like I got my 24.95 without any trouble. So I've parted this thing off from its parent body. Now I just have to clean this face up and make that collar 1.5mm thick. So I'm going to zero my cutter on the jaw face. Move back 1.5, and we should be where we want to be. I've just got this thing held in the 3-jaw without any protected things, mostly to maximise the chance of it being parallel to the centre of axis. I don't mind if it's offset a little bit, but I want this face to be perpendicular to the central line. Just a final clean up with a touch from this guy. We're done with the machining anyway. Obviously I've got to do the lapping inside. That looks pretty scruffy, but I can tell you it actually feels pretty good. I don't know why it looks like it does, but it feels pretty good for off the lathe tools. I'm sure it'll clean up well enough though with the lapping. So, a cylinder liner. So, getting started on the crankcase brackets. I've hacked off a couple of pieces of 25mm aluminium angle, and I've squared the other ends up, and so now I'm bringing these to length. So that's roughed them both to the same arbitrary length. So because I haven't decided yet what to do with the crankcase, which is nearly 0.5mm under length, I'm not going to take these to their final length at this point. I've just remembered that. So I'll take them to an arbitrary 55mm. The correct length is 54, but I'll come back and sort them out to their final length when I've decided what to do with the crankcase. So this is just a 0.68 depth of cut, just to bring them to 55, and then I'll park them for the time being. So this is my home brewed cutter. It seems to clean up pretty nicely on aluminium. It's a very fine surface finish. Anyway, so these get parked now, and we'll bring them back when I've decided exactly how long they should be. So I'm in a very noisy environment today. I've grumbled many times in the past about tradies building a house next door. You'd think they're building the Taj Mahal, the amount of time it's taking. Anyway, there are bricklayers there today, and then another crew chopping up metal and generally making a racket. So again, I have to just do the best I can. So I've decided to use this crankcase. It's you might remember from the earlier video, just under 0.5 millimetre short on the length, but I've looked pretty closely at the drawings and I'm reasonably sure that that isn't going to cause me a problem. So then I'll have a couple of choices. I can either machine the bottom face of the cylinder slightly undersized all round, or cut a couple of flats either side, or just put up with it overhanging slightly, and I'll decide that later. But for now I'm going to punch the 36mm hole through the top and drill 6 holes around it, which will be the bolt pattern for securing the cylinder. So I'll do this bore first, and then when I machine the cylinder I'll use this as a size gauge to make sure I get the diameter on the bottom of the cylinder right. Not sure what speed to use for one of these annular cutters. Pretty slow, I suppose. I just love these annular cutters. This one's 22mm and it'd be a good start for the boring operation. And one of the real benefits of these cutters is that they leave a very clean hole. There's very little burr on the back side here. So I'm underway with the boring head, and I seemed to get a pretty good result when I was doing a depth of cut of 2mm, so that's what I'm repeating here. So I'm closing in on the target of 36, and I'm hoping that this pass will take me to 34. Wind this back a bit so I don't score the bore on the way out. And get some of this stuff out of it too. Let's see what we got. Hopefully we'll be getting pretty close to 34. Alright, so what do we get? We got 33.95, aiming for 34. So I think I'll take another pass with the boring head on the same setting and see whether that brings us exactly to size, because that'll be useful to know when I get closer. And so I've just taken another pass on the same setting, and I could see there was a very light cleanup happening, and now I'm quite pleased with where we are. That's certainly close enough to 34 for me. So we're on the last lap here. I proved on the previous cut that a spring pass took 0.05 off, and I'm hoping that that'll work again for this one. Anyway, we're aiming for 36. Let's see what happens. Well, I don't know what happened there, but I messed up something. Got 36.15. I must have miscounted with the turns or something. I don't know how I managed to stuff up that badly. Anyway, hopefully there's enough meat in the top face there that I'll get away with it. Well, I guess that's what we'll find out next. Well, it looks like I'm going to get away with that. There's enough meat around there, I think, that it can still work. Okay, just got to do some tapping now. So while I'm drilling holes in the crankcase, I thought I might as well drill the hole pattern in the back face as well. This just has a plain cover bolted over it, so the hole is access to get the crankshaft in. Anyway, so the hole pattern is the same as the pattern on the front face, and I'm using a centering dial indicator to find the middle. And that's going to be close enough for this exercise. The plate doesn't register inside, it just sits on top, so as long as it's somewhere near it, we'll be good. Alright, that's finished drilling. Now I've got to do the tapping. Alright, so that's got the bolt pattern in the backside sorted. So I was curious to see whether or not the nose piece would fit. And as you can see, it does. I mean, there's a witness mark from where I was pushing it into the other end, which I was calling the front, and see, it's a good fit on that pattern, and I won't push it right the way in, but it actually has the same push fit in the bore. So the boring head clearly did an outstanding job of holding the diameter constant through that 54mm of thickness. So I was rather impressed with that. Anyway, now it's time to make the cover plate that will fit on this pattern. So it's a 61mm diameter disc, 3mm thick. And as you've already seen, it has a bolt pattern that matches what we've already got here. Now, my first idea was to try and... Oh, and I've got a piece of 3mm sheet, I don't know whether you'd call it plate here, scrap anyway, which is big enough to get a piece out of. But I want to run a smoothing cutter across both faces just to clean it up a bit. I mean, I could try and slice something off a 75 diameter round bar, but I haven't got anything quite like that, so cutting it out of this is the next best option for me. So I did think of having this on here, and I set it all up with the toolmaker's clamps and all the rest of it, because I was hoping that I'd be able to drill the bolt pattern through it after I faced it, but while I still had the setup. But I couldn't quite get the holes to line up with the holes in this angle plate. It's a Murphy one, that one. So, but with this setup here, there is actually enough space between these. I can't see very well, but there's just enough clearance between these parallels that I can do the smoothing cut and then drill the bolt pattern all in one setup. Yeah, I'm not happy with that. I realised that when I cut that out, those faint cutter marks are going to look weird on the round disc. So I'm not going to go ahead with that. That was a waste of time, as it turns out. But I realised that I do in fact have a piece of material that I can use. There was a bit left over from when I made the nose cone. I was thinking about using it for making a belt pulley, but I'm going to use it for this cover instead. So I'm parting a 3mm thick disc off here to be the back cover for the crankcase. A bit worried about how I'm going to catch it. There's a pretty deep parting operation too. Anyway, we'll press on and hopefully we'll be okay. You can probably hear the note changing there. So I think we'll won't be unnecessarily brave here. There we go. So I've got the disc which will be the rear cover of the engine mounted in the milling machine. I've got it clamped to a 123 block, and by sheer good luck the 8-hole pattern that I have to drill here, 2 holes go in each of those 3 sides and 2 here that actually match the holes, so I can drill all 8 holes with the one setup. Now I've used the dial gauge to make sure I'm correctly centred. Now I can only get to basically 3 sides, but if I'm getting the same reading on there, there and there, I have to be centred, so I'm happy with that. So time to bang 8 holes into it. So I'm quite pleased with the way that turned out. That's the outer face, but the inner face turned out fairly well as well. But maybe more importantly, as you'll see, all the screws line up with their holes, and it happily goes on in any orientation. And it's supposed to be 1 millimetre below the top surface there, but it's right on all of the other edges, which is where it's supposed to be. So that's turned out well. I haven't drilled the hole in it yet. There's a bolt hole to go in, which I think is for a drain hole, but I won't do that until towards the end, and I'll do it with the thing installed on the crankcase. So I think the next thing I'm going to tackle is the cylinder. Right, so I bought a piece of material to make this cylinder out of. As you just see, it's 80 diameter, quite a bit larger than needed, but I went to a specialty supplier of materials and went looking for shorts and offcuts, so I didn't have to pay for a cutting charge, and that's what I came up with. Anyway, so first job is to face it off and then take the OD down to the maximum diameter of the cylinder. We'll start with that. I think that's cleaned up well enough. There's a mark of some sort there, but that's going to be the bottom face. I don't think that's going to cause me any grief, so not waste any more material. So let's see if we can get this OD down to 57. I've got a fairly coarse feed on too. Let's start with 3 off the diameter and see what that looks like. This isn't going to be much fun, is it? So this will be the last pass, taking 3 off the diameter and bring us down to 60. Certainly reefs it off. Right, well that was set for 58. I imagine we'll be fairly close to that. 5802, that's right. Right, so we're sitting on 58. So I'll just repeat that last cut, set for 57, and I think that'll be good enough. You always seem to get a better surface finish on your second to last cut. Anyway, that'll be good enough. And I moved the camera out of the way before I checked what I actually got. Oh well, find out now. 5701. Well, I'm happy with that. As I said, it's just the outer diameter of the cooling fin, so it doesn't matter. Anyway, so I'm really wanting to sneak up on this 36.176 dimension, because I'm looking for a really snug fit to register in there. Yeah, 36.32. Right, well, given this reading slightly high, I think we'll just go for it now. Well, what counts now is whether we hit the mark with the hole. Well, I'm pretty happy with that. That was a perfect push fit, exactly what I was looking for a good registration. So I'm removing this material here to create a 12 wide recess, which will define the flange that the cylinder, with which the cylinder is bolted to the crankcase. So I've got to go into 35. I was going to square this up, but thinking about it, there probably isn't any particular reason for doing that. Maybe to make sure the bolts have got somewhere to go, I suppose. Anyway, that's what the drawing calls for, so that's what we will do. So I'm taking the final clean-up pass now. This is supposed to be 12 between faces and 35 diameter at the bottom. So that's what we're shooting for. See how we did. So this was supposed to be 35. 35003, well I'm happy with that. And as for the spacing, I'll go and get a gauge block. So I've got a 10 and a 2 here. Looks like we're a little bit tight. Only a tiny bit tight though. That's good enough, I'm happy with that. Okay, so I've machined lands to define the outer diameter of the fins. Now I'm using a 3mm wide parting blade to create the fins. Got to plunge that into 35. That's 2 fins. There's all sorts of noise going on now. The tradies are back next door and they've got their boombox going and study concrete mixers, so I'm afraid there's going to be a bit of background noise. I can't help it, I'm sorry. So what I'm doing now is opening the, or starting on the bore of this cylinder. It's nominally 28mm, but obviously I have to fit the liner in there as a press fit. And so I'm starting off, I've put a small pilot hole in. I'm opening it up now with a 1-inch twist drill. That's it for the drill. Time to switch over to a boring operation. So I think it's time to do a proper check on the cylinder that we want to use on the liner, and we've got 28.002 on the bottom there. I think that's grown a little bit while I've been holding it. It was 27.999, anyway 28. It has grown a bit while I've been holding it. 20, anyway, I deliberately made it so it was slightly bigger at the top than the bottom. Yeah, 28.005. Okay, so I just ran through at 26.5 and mic'd it, and it came out spot on. So I'm getting have some confidence now. So with this pass, I'm aiming for 27. $26,999. Well, I'm happy with that. Yeah, that's reading up, isn't it? If I can hit 27.999, I think that'd be about perfect. Now the other thing, of course, is how parallel it is. Yeah, it's pretty good. A bit bigger at the top, which is ideal, I guess. So now I have to decide my sizing strategy for the final cuts. So the last pass I did took 0.25mm off the diameter, and it measured up correctly at 27.75. So I'm happy with that. So I've decided to make this cut at 27.98, and have my fingers crossed. 27.98 is what I'm hoping for. Fingers crossed. Oh, you gotta love it, don't you? You gotta love this lathe. I would never have dreamed of trying to do that with my old lathe. Not in this universe. Alright, for the final operation on the lathe, it's time to put it off. And there we have it. Well, I think that's a surprisingly good surface finish for a parting operation. Yeah, I won't be touching that up. So all I've got left to do is take this burr off, and then there's a hole pattern for the top face to hold the cylinder head on, and a hole pattern for the bottom to bolt this to the block, and then what's left to do is put the liner in, but I won't be doing that just yet. Just as an aside, I find the easiest way to get this sort of burr off is just to go around it with a pair of pliers and squeeze it, and the little flats cause it to tear off the curve, and then it just falls off. Well, you might guess that I did the intro just before I did the outro. I confess, if that's appropriate, that's the case. I wanted to make sure I could actually do what I said I was going to do, because there's a lot of work in making this little devil here, and I didn't want to say at the start the stuff I wasn't going to be able to do. Anyway, so I'm very happy with the way that's turned out. It's actually looking like an engine now. All of the bolts have actually fitted together very nicely. This piece here fitted straight on, the bolt pattern lined up without any trouble. I actually used the dial gauge on the register, which is on the underneath of this, to dial it in and make sure I got everything lined up. Anyway, that's it for now. Thanks for watching, hope you enjoyed it, and look forward to seeing you in the next video when the journey continues. Cheers.